with the Italian government later on. Hello, Wim. Good morning.
Hello, good morning, Marco. How are you?
Fine, fine. And you?
Yeah, perfect. Ready for the show.
Good morning, Professor Wim. How are you?
Hello, Dr. Gupta and everyone from ICID. Good to see you. Thank you for inviting me.
You are looking great today. Yeah.
I have to be.
How is
Yeah,
weather in Netherlands?
yeah, it's good. Little bit end of winter, so temperatures are getting better. First farmers go to the field. So slowly, things are starting now.
Is Kukenhof open? No?
Yeah, sure, for sure. Yeah. So, do we have a good audience today? Did you get some nice registrations? Yeah.
Yes, yes. The
I
maximum
hope from different
number is
countries. That would be very nice.
yes.
Yeah, because I try to show examples from different parts of the world, where we have been doing some work. So, yeah, hopefully we get people from different national committees also listening.
Yes,
So,
definitely. How many is
50 crores, 51. It's provisions.
We still have 10 minutes around. So
that's fine. There's no worries. I think everything is.
Yeah.
You want me to share and see the slides are working?
yes, you can try.
Maybe just a quick check, huh?
Yes,
Just.
please share.
Uh,
Yes, we can see the slides.
it's okay, huh?
Yeah, it's okay.
Perfect. Okay, good. Ready.
Where are you, Wim, now?
I'm in my office in Wageningen in the Netherlands. So I'm home.
How's the
Yeah.
weather?
Sorry?
How is the weather there?
Yeah, it's okay. End of the winter. So 16 degrees, which for us is hot.
Yes,
In March.
quite hot.
And so it's still, of course, soils are wet from winter, but not so much winter rain. I think most of the rain was in northern Africa this year and in southern Europe, Spain at least, and Portugal. I'm not sure about Italy. Spain got a lot of rain. Morocco also a lot of rain. First time in 7 years they got heavy rain. So if Morocco is in a good shape now, um, yeah, and let's see what happens in the next irrigation season.
Yeah, this year has been kind of rainy here in Italy as well.
Yeah. Yeah, but our side it was dry. So really, we got very little rainfall in winter. So we are expecting a dry spring. So let's see. Um, yeah.
Why do you say you are expecting a dry spring?
Uh, it is maybe on the basis of experiences that when we saw several times a dry winter, also spring was dry. I'm not a climatologist, but perhaps that is a kind of pattern that we should be prepared for at least. So, yeah. And then Netherlands also becomes an irrigation country more and more. Before it was drainage country, now we're getting also irrigation country.
Okay.
Wow, 85 already, huh?
More than 500 people have registered this time.
More than 500, sir. Wow.
Really?
Wow,
Oh my God.
that's a lot.
From Argentina as well. My friend Alejandro Panunzio from University of Buenos Aires.
Okay. No, I know him. He's also one of my friends.
You know him? Ah, okay, that's nice.
He's a blueberry man, huh?
Yeah, yeah, yeah.
Yeah, yeah. I know.
Igor
Oh, that's it.
Kovalenko from Ukraine.
Wow,
I think from all over the world, yes.
wow. That's nice, actually. That's good, huh? Thank
Yes,
you
very
for
good.
doing this, huh?
No,
This is
no,
the
thank
only
you.
way to really reach out to all the different countries. Huh? See,
Yes.
ICID is very well established.
Also, people from South America, from China. This is very nice, yes.
100. Middle East democracy told differences.
Already 100 are ready to enter.
Yes, complete. 100.
So I have prepared, sir, for 45 minutes, according your suggestions.
Okay.
I will try to finish the introduction in 45 minutes and then take questions. Is that okay with you?
Yes, but if you want to take more time, you are free. Means we have time for this
Okay,
session.
perfect. Excellent. Yeah,
So
it's a new topic for maybe some of the people, so I'm
yes,
really ready, to answer all the questions they have.
yes, I will ask participants to write their questions in the chat box.
Yeah,
So
yeah.
after your presentation, you can take one by one.
Yeah, sure, sure. The first message from Oman is already there, from Zahir Al Salmani.
XOBs.
And I guess this session will be recorded, huh? So
Yes,
probably later on it will be accessible through the ICID portal. Perfect. That's very good.
it will be recorded and we will place it on our website.
Yeah, yeah. And then I will also make a link because also I have some 7,000 followers on my LinkedIn.
Yeah,
So then I can also link it directly to ICID.
yeah, very nice. Yeah. How many?
Yeah, new 150. Great.
So more than 150 has joined. We still have 3 minutes.
Fine. That means at least the topic was interesting for a broader group of people. So that was a
But
good decision.
everybody is waiting to hear you.
I'm going to say nice things, but maybe also a few critical things, huh? I
About
want to
what?
keep everybody sharp.
Yeah.
Critical things about what?
About the irrigation sector, we have to do better. We are not there yet. We have to really manage. We always talk about managing every drop of water, but I feel that is still far away. We have to improve on it. But I think there's also room. I will also show that there is tremendous room if we have more measurements. And we need more measurements for sure.
170. Prof.
Shall we start, President?
Yeah, I think we can start, yes.
Okay, thank you. Good morning, good afternoon, all the participants for joining, who has joined this webinar on smart irrigation management. And I welcome my President, ICID, Dr. Marco Arcieri, and our speaker today is Professor Dr. Wim Bastiaanssen from Netherlands. And he's an expert and well-known personality in remote sensing and smart irrigation management. And he will be delivering the talk today on daily satellite measurements to support smart irrigation management. Before I invite my president, Dr. Marco Arcieri, to say a few words, I would like to tell all the participants that Professor Wim Bastiaanssen is IrriWatch ambassador of Hydrostat and is currently visiting professor at TU Delft, the famous technical university Delft, the Netherlands. And he's the original developer of two energy models, Sable and ET-Look energy balance models, which are being widely used by private sector in academia globally. So now I invite my president, Dr. Marco Arcieri, for the presidential address before I give the floor to Professor Wim Bastiaanssen.
Thank you. Thank you. Good morning, good afternoon to all the people who have gathered for this very interesting webinar from all over the world, as we can see. And thank you for all our people in Center Office, coordinated by our Secretary General, Dr. Gupta, for organizing such an interesting and excellent webinar. And of course, thank you, Professor Wim Bastiaanssen, for sharing with us your remarkable experience, your skill, and for providing us with your insightful consideration at the end of this webinar or during this webinar regarding the smart irrigation and water resources management. We are talking today, I will be very brief, about how daily satellite measurements can help modern smart irrigation because they provide us with data, high resolution, actionable data regarding soil moisture, evapotranspiration, crop water stress, in order, of course, to optimize water use. This is what Professor Wim Bastiaanssen is going to show us, and allowing us to have decision-supported irrigation, which in some cases can bring us to have up to 40, maybe in some cases 50% of reduction in water consumption, which are the main outcomes, positive outcomes of smart irrigation management by use of satellite data. Of course, as I said, optimize water usage, because monitoring the actual plant water evapotranspiration, soil moisture, you can prevent underwatering and overwatering. Of course, another excellent outcome is the improved yields that the crops can be obtained. In this case, it has been shown, and I'm sure that Professor Wim Bastiaanssen will also talk about this. Recent data, research data show that yield can be increasing up to 25-30%. I think another important aspect of this approach is that you can have a proactive management of water resources, because farmers receive automated notifications when to irrigate, how much water to give, for how long. So this allows them to act before the yields are affected. And of course, this is also very important because it allows for it allows water allocation according to different areas of the irrigation district. And so they are very useful in managing, distributing, and for modeling water allocation, water resources allocation. So with this, I will give the floor to our esteemed guest speaker, Professor Bastiaanssen from TU University of Delft and from Hydrosat Systems. Thank you, Wim. Thank you very much. The floor is yours. Thank you.
Okay, thank you, Dr. Marco Arcieri, President ICID, and Dr. Gupta, Secretary General. Um, it is really a big pleasure to speak today about my 40 years of work in remote sensing and irrigation management. For those who do not know me, I'm an irrigation engineer from Wageningen in the Netherlands. And actually, I have been working in many countries. So I'm very pleased that you have today people from Argentina to China in this webinar. Yeah, I like to sketch my view, my experience. I will show, of course, many nice images from satellites. That is what you expect. Today will be a show with nice images. But also, I like to discuss practicalities on how to get to a higher level in management. So, the talk will be 45 minutes. It will be recorded and will become later online through ICID, which is great. It is a long series, 45 minutes, but I want to first sketch some background in irrigation issues and water saving. So I will really address the issue of water saving and increasing water productivity today. Also from a little bit from academic background, but hopefully also sufficient practical examples, so that you all feel um, yeah, interested, engaged with this kind of technology. So I will now start sharing my screen and hopefully you can see my presentation here. Um, so um, the situation is that long time ago, we started with agriculture, then we got a boost in the during the Industrial Revolution in the 18th century, and then that was followed later by the Green Revolution, which really enhanced all the crop production, which was good for the world. But now we are in 21st century and we have new challenges. We really have now the challenge of water scarcity, large population growth. So there is an issue of food security, and really things are not the same as they were 50 years ago or 100 years ago. So we have to think more about solutions. So this slide is data on global water scarcity. This data is coming from the World Resources Institute and also World Bank. And you can see here that by time, the scarcity is increasing. So before it was a kind of okay, but we see by time there is a change. Yeah, that is a serious thing. And especially certain countries are now either below the absolute water scarcity, like Pakistan and Egypt. Bangladesh is about to enter. India is still a kind of okay, but not everywhere, of course, depending on the area and China and so on. So I really hope that participants today are also representatives from those countries where water is scarce, and we have to do something about better irrigation. The goals of irrigation can be somewhat different depending on the design criteria a long time ago. But as a nice paper from the irrigation friends from Nebraska and Lincoln, they wrote actually, that it is about making more profits and to get yield, but also it's about optimizing water and quality of products. So there can be different reasons for the irrigation, and of course, that is a national thing. It's a national policy. But sometimes it's good to realize what is this? What do we want to achieve? For sure, if you want to say something on the success of current irrigation practices, it is essential to have a number of indicators, performance indicators, and classically, as student, you learn about efficiency, improving irrigation efficiency, and to minimize system losses. More recently, we talk more about water productivity, also supported by FAO, right, where we can get more yield per unit water. But in other countries, equity, like in Pakistan, for instance, is very important. What is the social cohesion? Are people getting all the same amount of water or not? And is it adequate? Where is the stress occurring? Are we sharing the stress? Or we are not sharing the stress between different canals, between different command areas, maybe even between different farmers. And is the system reliable? And it's always being argued for the last 25 years that irrigation should be based on reliability so that you know when the water is coming. So you can invest. You can invest in particular crops, in particular inputs, farm inputs, because you know the water is coming. Um, what is actually a big issue in my view is that irrigation is not really measured and is also very often not built. So on households in many countries, we send bills and we have meters and we use only maybe 100 liter or 80 liter, 120 liter per day per person. But if we go to fields, then actually we use much, much more water, and most of the time it is not really measured. So we want to improve irrigation. We have seen water scarcity, but we are not really measuring the water flows in the systems. And that not only relates to canals, but also to groundwater pumps. In many countries, groundwater tables are falling and are still falling. It did not stop, it still continues. And one of the reasons also is that the amount of groundwater being pumped is not properly measured, not properly registered. Sometimes this may be measured, but then not shared to the responsible agencies. So there is a quite a challenge in measuring our water systems. Yet we want to know whether we are improving or not, and whether we already reached our maximum efficiencies or not. And this is a slide of earlier work done with Pasquale Stedito from FAO. This is about water productivity, yield per unit ET. And it is for different countries. And it's very interesting to see that there is an enormous range. Some certain countries are below the 0.5 kilogram per cubic meter. This is for wheat. This is data for wheat, but also we did it for some other crops. And also you can see at the other end of the spectrum that countries like, that are very high. I will not mention countries. My point is more about we see almost a factor 5 or up to 10 almost difference in national scale water productivities, which considering the environmental situation we are in, yeah, it's not ideal. We know we can do better. Today, talk is mainly about satellites. I will come back to many images as I promised you. But this is a study from Vietnam with ADB that shows this water productivity. And for mango and pepper, and coffee and rice. And what is very interesting, I found, is that independent on the type of crop, we see tremendous variabilities of the water productivity. So it's not that some farmers are 10% more and other farmers 10% less, but it's huge. So that means also that there is a lot of possibilities to improve. And this is one of the slides that is based on satellite measurements. But for me, it's the slide of the year because it shows really a few very fascinating aspects. This is from a cotton field in Asia. And whereas at the one hand, we saw tremendous scarcity and increasing water scarcity, we see on this slide that for the same area, for the same agroecological zone, tremendous variability. So here is the yield of the cotton, and we can see that some farmers are only having the 200 kilogram, other farmers maybe 700 kilogram. We also see that farmers use 200 millimeter of water and other farmers use 1,000 millimeter of water for the season. And of course, when you talk about this scarcity, that is like, wow, that is huge. And this is an example of an analysis based on satellite data. It's not published yet, but it also shows the water productivity. So let me show maybe two important things. One thing is the red line. So you can see that if you irrigate more, your yield go up. And then there is a certain ceiling. And even if you irrigate further, you see the yield goes down. We know that. We know from our education that this is happening. Yet, in reality and operational conditions, this is still happening. What I found also very interesting is this purple bar. See, some farmers in the same agroecological zone, so the same climate, same rainfall, same temperatures, some of them, they use this amount of water, like 300 millimeter, and other farmers for the same yield, they use 1,000 millimeter. And that is something, dear participants, we should not longer accept. This is not good. We all know that. But if we don't measure it, then you cannot take actions. So I think there is tremendous scope to improve, but we need better data. And this is based on some 17,000 fields. There's a lot of data being collected from satellites, but it gives you also tremendous insights. When I go to a farmer and say, "Hey, you're using too much water," they always say, "No, no, 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 I'm very good." They always say that they are somewhere here in the yellow and the yellow part with high water productivity. But sometimes they are not. But also they don't know. So we have to guide also farmers and irrigators more about how to move from the darker blue areas with low water productivity to the yellow areas, where the whole efficiency of using scarce water is much better. And as Marco already said in the introduction, there's also a possibility to go from the 400 maybe to the 600 kilo. But that's an agronomic thing. And that is, of course, possible if you have investments for fertilizers and other things and tractors, and you're not on a stony slope of a mountain where maybe yield improvements are not so easy. Okay. What is also possible is to save on ET. There is some understanding by people that say we can save on water applied, but not on ET. And that's a misconception. Okay, this is a literature overview. In this case of rice, of yield up to 12,000, so 12 tons and 2 tons. But here on the horizontal, you can see ET. And the same picture, as I mentioned before, can be witnessed here on ET from 500 millimeter to 1500 millimeters. So we can also save on ET. But we have to learn about the separation between the E and the T. So here is the big thing. The evaporation is non-beneficial. It happens between the rows, especially when you have a lot of flood, and if you have ponding water or the tail end of your fields, then you have a lot of non-beneficial evaporation. And transpiration, of course, gives crops. That's good. So actually, it's all about, you know, bringing the water to transpiration and avoid evaporation. Now, one standard question I always get is, well, how much is this non-beneficial evaporation? And my experience in general is 1/3. So 2/3 is T and 1/3 is E. But it can be more. So if you really have more waterlogging or drainage problems, the E can be 50%. So it is really essential to not longer think about ET, but also about separation of E and T. This was also already a long time ago discovered, and nice publications of FAO about it. Also, the whole aqua crop model is based on the fact that you should keep up your T. T you cannot reduce. If you reduce the T, you reduce your yield. So we like to do water savings, all super good. Lower recharges, lower runoff, all good. But don't reduce the T, because then your yield and your income will go down. So a different way to make a statement is that we should look at the withdrawals, and then we should look at the beneficial and the non-beneficial. And it's all about increasing the beneficial. So it's about T, and we should then really look more on what happens in the root zone. So civil engineering is very important. They bring the water to the farm gate with pipes or with canals. And of course, with piped water, you have much less losses, which is good. But good irrigation management is not only about efficiency and these conveyance losses, it is also really about what happens in the root zone and improve the situation in the roots. And that is more the classical, soil management and crop management and so on. Now, when I talk to my brothers and say them that, hey, you don't need to irrigate because your soil is wet already, they laugh at me. Okay, they don't take me serious. I hope you take me more serious. Like, we can really look what happens in the root zone through remote sensing. I'm going to give you many examples now, and that is meant to really convert the applied water AW into transpiration. And you cannot do that on the basis of intuition. Of course, farmers are proud and they have a lot of experience. There's no doubt about that. But they cannot stand at a field and then say something about the root zone moisture status. They have to make a decision on, is the soil moisture at field capacity, and where is it? And we all know that, from classical theory, that we want to have some air inside, maybe lower than field capacity, but before you get water stress here, you should irrigate again. And again, it's very difficult to see from walking around. So these practices of using your intuition and flooding, yeah, somewhere it has to be changed. And I know this is a hard message. I know many countries in Asia do flood irrigation as standard practice. But I see also very nice modernization programs like MCAT in India, where really they go to more modernized solutions with pressurized water distribution, etc. And so that's very good that this is happening. Also, on rice, there's a lot of developments to reduce the methane reduction of flooded rice fields. So also there in many countries, you see already programs being started, maybe some pilot programs, sometimes already at larger scale. So this is all good. And if you a little bit summarize my first 20 minutes, then it's really about, well, we are not there yet. We are still have to do much better on water saving and bringing exactly the right amount of water to the field. So I believe irrigation management is absolutely something that will get a new era. And of course, um, I'm really convinced satellites can measure things that otherwise cannot be measured. Okay, because satellites can measure things like soil moisture, but also like ET, as Dr. Marco was mentioning. And ET is not, you cannot get from a weather station. That's a classical mistake. A weather station gives you reference evapotranspiration, but not actual ET. So you need something else. And in fact, I will come back in a minute on why we use Pannon teeth. Okay. But satellites are cool. We can measure things. We can see individual fields. We can see canal command areas, tertiary canals, minor canals, distributaries. But the thing is, are you ready? Are you ready for that change? Maybe one thing is you first need to be convinced. Number two, how do you use the data? Well, the good thing is there are many startup companies. I'm working for one of them, Hydrosat. There are many more that already start providing this kind of information on an operational basis. So no longer you have to go first to the local academic researchers and do 5 years of research and another PhD and then finally use the data. No, you can now already for very affordable prices sign up and get this data at your fingertips. And that is already there. But also for governments, they have to start using this. And this is a picture of the service that I developed a number of years ago called IrriWatch. And IrriWatch is now being more and more used also by governments to look at, okay, what is the total water requirements? Are our guidelines for irrigation good or not good? Yeah, there is really a lot of interest. So the message here is that it's not academic research. I did my PhD in 1995, that is 30 years ago. So we have made progress. That's the good message. So here is an example of a thermal map from satellite data. This is from Van Zyl satellite, one of the satellites of Hydrosat. Hydrosat has their own satellites. It was a very hot day in July last year. Some areas in the town of Seville were even more than 60 degrees. And then if you look to the irrigated fields, they're all in the darker colors, here in the darker purple, maybe only 30 degrees. Clearly you can see all the irrigated fields, So that tells you everything on water being available to cool down the land surface. So the number of satellites are growing. Also, the European Space Agency is going to launch new satellites. India Space Agency, together with the French, are going to launch Trishna next year. And that's fantastic. We get more and more frequent thermal measurements. So here in the red, you can see measurements from satellites. Then on certain days, maybe there was no satellite or there was some clouds. But really, by doing physical modeling, you can get the leaf temperature for every day. So we really now can monitor very precisely leaf temperatures. And that is interesting because that information can be used to calculate ET. So here a little bit science before I go to the applications. And this is an energy balance, and the energy balance is very easy. It's an ET, an actual ET flux. That is the difference between the net radiation and the soil heat and the sensible heat. Now, some of you may recognize, they say, oh, but it's almost like Penman-Monteith because that also has ET, it has Rn, and it has the G. The only problem is Penman-Monteith does not have the H, and the H is really based on thermal satellites. Now, Penman's work is from 1948, Monteith's work is from 1965, and of course, at that time, they did not have the capabilities of measuring the temperature. So they could not solve H. Okay, therefore they developed the combination equation with the resistances for aerodynamics and surface resistances as an alternative. But really, it was created because they could not measure H. Now these days we can measure H every day. Okay, so in an irrigated field, the temperature is low. The majority of the radiation will go to ET. And on a fallow field, it's very hot, and the majority of the radiation goes to sensible heat flux. That's the science. So, one of the models, as Dr. Gupta mentioned, is the CBAL. It is a model that I developed some 35 years ago. It requires satellite measurements of albedo, NDVI, and temperature. So this is a certain catchment, and here are the input measurements, and then we have CBAL, and then for every pixel, you get this actual ET or latent heat flux, and this is really being used now. I don't know how many myself. I use it in more than 70 countries, but I see sometimes many publications passing by of other countries also using CBAL. One of the things why CBAL became popular in the irrigation community is that it calibrates itself. So by design, I thought of, wow, how do we solve this sensible heat flux? So I introduced the concept of hot pixels, like here, and cold pixels. And then I said, look, between those anchor points, I scale the sensible heat flux, and then I can get directly to actual ET. So no new science. Maybe it sounds new to you, but really this is from 35 years ago, and it's already being used in many countries. I'm very happy to, again, Pasquale Steduto, who actually in 2022 made a very nice report, 23, sorry, about the change of determining ET from the traditional FAO 56 that most of you have on your desk to remote sensing determination of evapotranspiration. Now, I know that this one is not on your desk, but please put this one on top of this one on your desk, okay? Go to the new things. Don't think this is only promoted by certain people. No, this is really an FAO piece of work. And by the way, the FAO 56 main author was Rick Allen. And if you follow Rick Allen, if you Google his name, you will find out that he is actually also completely converted away from the traditional reference ET to remote sensing ET. He has a model called Metric, which is a sister of CBAL model. So Rick and I worked for 10 years together on CBAL and Metric, and these models are now really operationally used. These are just a few examples on the accuracy. So here are a few different tables. So one is showing the US, here different states in the US. So overall, the difference of the ET for the season between the field measurement and the remote sensing. So 1% difference, 5% difference. Let's say typically about 1 to 5%. Here we have Sri Lanka, Pakistan, Australia, Philippines, Turkey, and South Africa. More countries. Actually, it's more or less the same. So more or less we can say, hey, we know actual ET, We can compare it with equivariance. We can compare it with scintillometers or surface renewal, which actually is becoming very popular again these days through CropX. And we can see that there is only 5% difference. Honestly, I think also the field instruments have these problems. Also, the field instruments are not 100% correct. So if we have 5 to 10% differences, we should be very glad. Just to show that not only we do this in Europe, but this is an example from Mexico via the Yaqui, but also, you know, a long time ago, we did some comparison between CBAL and the equivariance fluxes. Very nice agreements. Another small piece of background is the fact that we can measure this ET. I've now explained we can measure ET. But if we look a little bit to why water is flowing in the crop, then there is a difference in soil water in potential. So here is the soil water potential in the root zone, and then it goes to the root potential and the leaf potential, and finally it goes into the atmosphere. Here, the water is withdrawn in liquid. Here, it leaves the plant in vapor. Okay. The nice thing is, if we know this transpiration flux, then actually we can back calculate the condition of the root zone, which is a soil water potential. I'm very happy to say that Hydrosat is really world leading now on measuring this soil water potential, or actually tensiometer is the same. You put a tensiometer, also you measure soil water potential of the root zone. So there is no need to go to the field and dig and install, but we can directly say something about the soil water potential of the root zone. Now, you may remember from your studies about the water retention curves, but if we know the soil type and the water retention curves, we can convert this soil water potential, or some people call it soil suction or soil pressure head, we can convert this into moisture. So in other words, we can get ET fluxes, we get the T, we get the potential, and then we can get the moisture. Of course, it's also been validated. I just give you some examples. This is from Almonds, together with UC Davis in California. Here in India, with the onion fields, with the water organization. Here is in Guatemala, in sugarcane, and in Chile. So, yeah, many of those things have been compared. So if you think like, can I really use this remote sensing? Yes, you can. It is validated. Here, one more example. The left hand, you see again the energy balance. The ET is computed from energy fluxes, not from water applications, not from a water balance. No, directly from the energy. And that ET you can actually put into a water balance. You can add rain. And then actually the big unknown is irrigation. So from the water balance, then we can make estimates of, well, how much water has been applied. Few validations. This is a study by the Department of Science and Technology from India, jointly with the same department in the Netherlands, NWO, where in Hindon River in Uttar Pradesh, we also looked at the applied water and from irrigation, from remote sensing, and from field measurements. Of course, they always see a few differences, but the nice thing is that if you put some 5 or 10 fields together, it's almost identical. Maybe per field and some differences. Same you can see here in Madeira County in almonds and pistachios with David's engineering, where also they measured the applied water with devices, special devices, and then we also did some calculations, and you can really see some nice agreements. Last part is about the crop yield. So a clear objective is to save water, but not to impact crop yield or to improve the crop yield. Now, there are many different ways to do that, but one method that I have been using for a long time is the biophysical system approach, where the green part on the left hand is the leaf, the blue part is the air, and we can see that the water is flowing, coming from the soil here. It's liquid. It goes to the leaf interior, and then here is the stomate or stomata. Here it vaporizes and the water vapor goes out. But the carbon is getting in through the same opening. Okay? It's the same openings. So if we model the T, we can also model the carbon flux. And if we look at light, so we have different satellites that measure, by the way, the solar radiation at the crop every 10 minutes. And this is done for the whole world. So there are different geostationary satellites, but if you put them together, every field in the whole world, every 10 minutes, solar radiation can be measured. And then we can calculate the photosynthesis and crop production. Now, this is the last slide on the validation. The left hand is a John Deere that were with a combined harvester with a yield sensor. They measure the rice yield on the left hand. The right hand, you can see the IrriWatch. This is 10-meter pixels, and you can see overall there is really a nice agreement. So, what have I said to you? That irrigation is still beginning. We are not there yet. There's still a lot of things to do. We can save water and at the same yield or maybe improve yield, but we have to give more attention to our roots, our root zones. So how can we deal with that operationally? So here is an example of soil moisture in the Bangkok Plain, together with the Royal Irrigation Department in Thailand, the Kasetsat University, where really moisture is measured by satellites every day, and then this information is used also for irrigation scheduling. So the moisture is in the root zone, it is measured every day. So don't think like, oh, but Sentinel is coming only once in 10 days or Landsat once in 16 days. No, there are more satellites. There are also mini satellites being launched. Space organizations also have more satellites. So we get more and more opportunity. We can then also really look at the moisture locally or ET. Here, left hand is a moisture. This is a Morocco. The right hand is ET. And ET, again, is very difficult to measure in the field. So it's nice to have this kind of additional information. The service that Hydrosat is providing is based on alerts as well. So every morning at breakfast, you get an overview, how many hectares, there are so many hectares, so many fields, and 53 fields need attention on the moisture on irrigation. 42 have more an agronomic issue, but this information is updated. So the latency is less than 1 day. So you don't need to wait for a long time. You can directly subscribe. And then also it will tell you which fields require more attention than other fields. So it can really tell you like this field, La Felicidad really is this field. You really have to go there today. Go now. Okay. Don't wait until tomorrow. Go now. These kind of things are there, you know. And then also we help. We help farmers at field scale when to irrigate, which day. So there is a weather forecast for the next 7 days. Here is a situation, no rainfall. So this is the irrigation advice that you have to give, which depends very much on predicted cloud cover, predicted temperatures, and then the actual ET, not reference ET, but actual ET is computed as a prediction for the next days. And that can go up to the level of sprinkler lines. So we can say, okay, here we have sprinkler lines. Every sprinkler line is about 22 meters. Well, actually, those ones that are dark, the advice is 0 millimeter. No need to irrigate. But some of them you have to give 4 millimeter or 9 millimeter. And you know what? This one actually 23 millimeter. That is already operationally available. And we have those maps of tangiometers. So even if you have variability within fields, you can say, okay, I make zones. This zone, I will give less water, oh, sorry, excuse me, more water. The blue one is moist, maybe less water, or you skip. Uh, of course, we always think about center pivot management with variable rates, and that we can do the same. We can also create zones for center pivots, but it's not only center pivots. We can basically also do for any other thing. So the whole variable rate irrigation is coming very near. Already, we provide it to millions of farmers, and it's very interesting to see that also the smallholders are taking up this kind of very local irrigation management because they can sometimes really bring the sprinklers exactly on the place where we tell them to irrigate. This is for smallholders, for field scale, for farmers, for water user associations. But we also want to help the regional scale. And then, yeah, when you talk about regional scale, also you want to say something about how is the performance. This is a slide from IJsbrand de Jong, who really from World Bank, who really made a very nice overview on why these performance assessments are really needed to compare between units, but also between irrigation schemes and provinces, but also to really agree on an irrigation service delivery. And also in India, you can see more and more that there is an agreement made with a local consultant who can bring the water to the farmers. So again, we can look at the regional scale. So note not at field scale how much water is needed, but this is an area in Morocco of 4,000 hectares. We can calculate which area is irrigated because you can see in red that not every field is irrigated, which is interesting, huh? So you can use generic cropping calendars, but sometimes farmers deviate from the cropping calendar. And so it's nice to know which fields do not need water. But also, is it equally shared, or actually water is stolen often? So here is a main canal, and often the flow in the main canal at the pumping station is measured, but the discharges after the pumping station are not. So in secondary canals, the flows are not always known to the irrigation districts and to the irrigation agencies. And what you can see here is the total ET in a millimeter per season. And you can see in the red one is maybe 600 millimeter, but in the blue one actually goes to 900 and 1,000 millimeters. Now, of course, if you talk to the farmers, they say, no, no, we are not taking the water. Everything is perfect. Everything is nice, equal, but it's not. So if you really want to intervene and if you want to do irrigation management with more precision, you have to start using these remote sensing data for moisture, ET, soil water potential, and so on. Applied to water, that is very important. Adequacy, example from LBDC in Pakistan, Lower Baridor from Bakas. And actually, this shows an area of almost 1 million hectares. And they always want to make things equal. But the pixels in blue have no water stress, and the pixels in yellow and red have a big water stress. So we can see here that things are not happening according to the plan. And sometimes people may want to hide that. They don't want to know. They say, no, no, everything's fine. There's no problem. No, if the phone does not ring, there is no problem. But really, if you want to use every drop of water more wisely, you have to really think on, are we going to continue the next 10 or 20 years, or are we going to introduce changes? And one of the changes is to start using SCADA systems. Cat is a company that I have been working with already almost 1 million hectares they have in India, and they can really bring exactly using SCADA and using remote sensing data, the water to the place where it's really needed. So instead of having big canals and fighting, they can really bring the water exactly where it's needed. So For instance, these are subchecks, and for every subcheck, it's specified the date. So this one is the 31st of January, this is the 1st of February, and so on. So you can see when those subcheck needs water, but also how much water should be provided. Because why should you irrigate if the soil is already wet? It's the first water saving to not irrigate. So, but again, it's not so easy to say, okay, son, today we're not irrigating. Who makes that decision? I think many people are willing to do that, but how do you decide? How do you have to trust that the crop is not impacted? So I believe that frequent satellite measurements, I'm talking here, daily high resolution satellite measurement can provide support of day-to-day operations. We will at Heidelberg also launch more products for the regional scale on irrigation planning, water use tracking, and performance indicators, including water productivity. I think those tools have to be made available at affordable prices. Because I was hoping 25 years ago we will get flumes everywhere and all the gates will measure discharges and all the QH relationships of gates will be improved and calibrated every year. And it's not happening. And it's not going to happen in the next 25 years. So we really better start to think about using satellite data. After the very nice global irrigation forum in Malaysia, I was asked also by the Irrigation and Drainage Journal to make a review paper. It's almost almost complete now, but I really would like to publish also these findings and experiences in ICID context. So conclusions. I think we have a lot of good knowledge about the irrigation. Education is good. We know how crops work. We know about soils. We know about civil engineering, but we don't have sufficient field measurements to understand where we can improve. And I doubt irrigation departments have the capacity to really invest in large-scale measurement programs. So I believe it's smarter that the irrigation society as a whole is going to move more in towards the use of remote sensing. And we have a huge problem of water scarcity, but I see so many differences between fields, sometimes neighboring fields, between canals, between areas being served by a certain SCADA system. So, but if we don't measure, we don't know. So we should go for more frequent measurements for both the farmer and the irrigation institution from the government, and create also more flexibility. I'm sure that once we have a better observation network, we can also introduce more changes, and we can really, and we should involve, I should have written down also more young talent, more young professionals, because I believe irrigation management is going to change from classical canal operations to smart irrigation at the field scale. So thank you for listening, and I think now it's time for questions.
Thank you, Professor Wim, for the excellent presentation. It was very, very informative and very nice presentation, I will say. And I will request participants to write their questions in the chat box. And I will request Professor Wim to just look at the chat box. If there are any questions, please answer these questions.
Two questions.
2-3 questions are there still.
Sorry, Secretary General, maybe we can ask participants to write down the questions in the Q&A box rather than the chat in order to have a better distribution of the, because in the chats there are many comments as well.
Yeah, indeed. And I'm now scrolling through the questions. I think one question is from Luis Fernandez on, do the clouds have image impact on the thermal? Yes, that's a very good question. Um, Clouds will absolutely contaminate the thermal signal. But by having much more satellites, many more than before, we still have more capabilities and more chances to find also moments that are not clouded. Um, this is one thing. The other thing also, I showed one slide, actually for this purpose, that we can also compute the leaf temperatures and the soil temperatures under clouded conditions. Of course, it's not a measurement then, but it's like a model, that can do the estimation of the temperature under clouded conditions. So what should not happen is that you have clouds for 5 days and then there is no measurement, because then you cannot build an operational system. So we have a number of solutions to reduce um, the impact from clouded conditions. Pixel size, yeah, depends very much on the type of satellite. Hydrosat has 10 meter by 10 meter every day. So that is something interesting, because 10 by 10 meter means also you have sufficient pixels to cover smaller fields like 1 acre, sometimes even a little less than 1 acre. Usually I like to say 1 acre size, say 4,000 square meter is the minimum that we can cover with 10 meter. With 30 meter images, that is not possible. There is a question on the cost. Many open access satellite data are for free. So the Indian Space Agency Trishna data will be coming for free. Very nice. Also, NASA, ESA satellites are for free. Hydrasat is commercial, so we have to charge, but we like to charge more for our irrigation service. So our IrriWatch is the irrigation service, and the price varies between €1 per hectare per year to 13 euro per hectare per year, and depends on the size of the area being involved. So if we have 100 hectare, we have to charge a different price than if we make an agreement for Andhra Pradesh where we can monitor 3 million hectares, of course. Isotopes, ET partitioning. I have no idea. I don't know about isotopes for ET. I cannot answer that question. What about woody crops? Yeah, no problem. To my surprise, I wrote a long time ago a paper on the ET of mango. And now every year I'm invited by the International Mango Congress to come and give a presentation, because apparently that's the paper that they all use. So it was very accurate, and they say it's very useful. So we can do also woody crops and grapes and almonds and pistachios and so on. So that is not really a limitation. There is another question from Zolo. Could you share experience with Vapor ET 300 meter? Yeah, that I know this product is also available. I'm not having so much direct experience with the quality, basically because yeah, I'm using more the product of Hydrasat. It will be very interesting to compare. So maybe that is a very good idea to set up comparison. And perhaps if you Google and search on comparison of Wapper and Seaball model outputs, maybe already somebody has done this kind of analysis. I don't know. How can yield and water productivity be estimated? Okay. So Mahmoud, um, yeah, water productivity, you need always yield on the one hand, and then you also need to know the water component. So it can either be ET. Um, Yield per unit ET is very interesting for water resources engineers. They want to know how much water is evaporated because it's a sink of water from the catchment or from the river basin. That water usually does not come back as rainfall because it comes back as rainfall over the ocean. So it's important for water resource engineer to know the yield per unit ET. But for irrigation people, it's much more interesting to look at yield per unit of water applied, which also is something we can do. I explained already that the yield is based on photosynthesis, that we can compute from the stomatal conductance and the carbon fluxes. So that is one way to get yield. And the amount of water being applied is taken from the soil water balance. So we prepare a soil water balance where information from rain gauges is used or open access information of rainfall products. We get a number of growing rainfall databases that become openly available. India, for instance, has a very nice India Meteorological Department rainfall product that you can use for studies in India. So then, yeah, we know on the one hand the yield, on the other hand, we know the ET and applied water, and then if we combine them, we can really get to water productivity. Water productivity is crop dependent, say because the yield of banana and onions and potatoes are rather different. So information of crop type is required, which also is and remote sensing activity is being done for many years. There are many different solutions to do crop mapping. Also, the Google Earth engine provides many standard algorithms to do crop classification. So if you really want to look at water productivity and not biomass water productivity, which WAPOR is doing, then you have to make a crop map. That is something essential. And my experience a bit is that it's perhaps the most difficult part. So we think crop mapping is something we do for a long time, but operationally, we are not exactly there yet because you need field data, field checks, ground truthing, and so on. Whereas the whole calculation of ET and so on, that can be automated. We have done for many years, these algorithms are stable. I showed you validation papers, validation comparisons, and so on. Okay. Now, next questions, and maybe I'm missing some questions, but one question from Noha. In your opinion, the biggest barrier to get daily scheduling data in millions of smallholders? Okay. I think the question here, Noah, is also how to reach to farmers in Egypt. And that is only possible with mobile phone technology. And what we often do, we work with local providers. So we work with local ag tech companies. So I'm working, for instance, with Tamkeen for a long time. Tamkeen is an Egyptian company. They talk to farmers, they speak farmers' language, they have their own mobile phone application in Arabic. And so we deliver all this daily data at breakfast to Tamkeen, and they then convert it to the farmers. And it can be thousands of farmers, there's no limitation. Don't think that I expect an Egyptian farmer to come to Hyderabad and say, hey, I want to sign up my field. That is not going to happen. But together with local partners, we can set up a nice system. Vapor should be validated. Yes, good. Oh, I don't. Okay, there's a question from engineer Fatma on irrigation analysis within ArcGIS Pro. I don't know, honestly. I have no idea whether there is. I'm not so sure there is something like that. If there is something like that, often it's based on weather stations, and which is okay. Um, but it should be more than weather stations. It should also be on soil moisture tracking. It should be on what is the critical water potential before you get stressed, and is it coming the next days, tomorrow, or after 8 days? So you know how much water in storage can be used before stress is triggered. And that brings back the issue of root depths and water storage, because if you have 30 mm storage, yeah, you have to irrigate almost every other day. But if you have 150 mm storage, because you have deeper roots or more clay soil with higher water holding capacity, then also this impacts the duration between consecutive irrigation provisions. I'm not sure ArcGIS is including all those elements. I think it's better you work with really irrigation engineers. Okay, it's a very interesting question from Sarah on eddy covariance. Is it important yeah, of course, eddy covariance is important. Meteorologists love it. My irrigation friends don't like it so much because I think the non-closure of the energy balance is not properly communicated. Eddy covariance usually has an error between 10 to 20%. And when they show the results, then that error is solved. And there are different ways to solve that. And I think the fact that the original measurements do not give a higher closure means also you have to be a little bit careful on using it. So it is useful, it's nice, but sometimes a very good lysimeter can do an equally good work. Of course, lysimeters is expensive. You have to babysit a lysimeter because if the crop is deviating in the lysimeter from the surroundings, yeah, then you have a new problem. So it's maybe also not the best. Then there's a question, the accuracy of the crop classification, yeah, that depends on the type of crop. Usually rice can be classified with 95 or 98% accuracy. But if you want to separate onions from garlic, for instance, you have a bigger problem. So it depends a little bit on the type of crop and on the amount of field work. For sure, all the AI modeling and all the cloud computing capacity from the last 5 years have absolutely contributed to reduce that error. So it is possible to make crop maps. Did I forget something? I think I have addressed most of the questions. Maybe we can ask for some final round of questions that people can type.
I see on the screen somebody, Director General, who has raised the hand. I don't know who is he.
IMTI Tamil Nadu.
From Tamil Nadu. You can ask the question by unmuting yourself. Now, I will request the participants to send the question. If they have any question, they can write to Professor Wim through email. And I will request Professor Wim to answer as many questions as possible through email. And before I request President Dr. Marco to say a few words, I would like to announce the next webinar in this series, which will be held now on April 16th. And the flyer I will show. Flyer is, can you show the flyer? Yeah. Yes, the topic is bringing together technology, innovation, and people to enhance water efficiency. And speakers will be from L&T department. And they will be talking about Kundalia irrigation project in India, where they have applied smart irrigation management, and it will be a case study. So it will be on 16th of April at the same time, 2:30 hours in the afternoon, IST, Indian Standard Time. So, so now I request President Dr. Marco to say a few words.
Yes, thank you very much, Wim, of course, on behalf of the hundreds of participants that have gathered to this webinar from, I must say, looking at the origin coming from really all over the world. So thank you for providing us with these very, very insightful messages and hints and advices. And there is a way. We know there is a way forward. We are just at the beginning, as you said, and this is very important. But I think we are on the right pathway. So I'm really, really very, very thankful to you for providing us with this nice presentation. And of course, I'm very thankful to all the participants with their questions. And I'm sure that Professor Wim Bastiaanssen will be providing the correct answers to all of the many, many questions. We had almost 300 participants, so I hope you will be patient, understanding that because of time limitation, we cannot answer all the questions here, but Professor Wim will make some time to answer to the many interesting issues that have been raised. And of course, my heartfelt thankings also to Central Office, my colleagues from Central Office, Secretary General Rakesh Gupta. When we developed the program or the webinars that we wanted to have during this year, we were sure that irrigation scheduling, irrigation advice was going to be one of the key topics of this season. And also thank you for already providing us with the next webinar, which I'll be looking forward to participate to. As a president of ICID, of course, it's an honor for me. Seeing so many people showing interest and appreciation for what we are doing. So I'm very happy about this. Having said this, I will say goodbye and give you appointment to the next webinar, which is going to be, as said by Secretary General, on April 16. Hopefully by that time the situation will be a little bit more calm, clearer, because we hope that as many of you as can participate will like to gather and join our anniversary Indo Summit. We have launched this tradition on 24th of June. We host in Central Office in ICID. We have this Irrigation in the Water Summit. And I think, if I may say so, this will be a great occasion to exchange information. We will invite, of course, excellent keynote speakers such as Professor Bastiaanssen, our former President Honoraire, Vice President, International Organization Officer. So I invite you also not only to join our webinars, but also to participate physically to our initiatives. Next one is going to be in Delhi on the 24th of June, and we also will organize some trips. So I say goodbye to you, but in the same time, as we used to say in Italy, we say arrivederci, which means we are going to see each other very soon. So thank you very much, and it has been a very nice webinar. Thank you. Thank you to all of you.
Yeah, I am grateful to President Dr. Marco for sparing the time and joining this webinar. And I am grateful to Professor Wim for this excellent presentation, for giving his consent to make the presentation on this series, what we have. And I am sure that participants from all over the world must have learned a lot. And they must be disturbing you in future by writing mails and asking different questions. And if we receive some questions for you, we will pass it on through email, so you can reply that. And we will be requesting you to share your PPT in PDF so that we can put on our website also. So I'm thankful to all the participants for joining the webinar, and hope to see you in the next webinar soon on 16th of April. Thank you all. Bye-bye.
Bye-bye.
Bye-bye. Bye-bye. Thank you.
Arrivederci.
Arrivederci.